Start the recording. And we have a smaller group today. We have one who can't be here with us. So today we're going to cover several topics. We're going to start out with this thing called a cartographic processing tool. And then we're going to use expression-based symbology. And that is going to be our first task is to create a map that kind of looks like this. So here, there were a lot of, this is of the United States, but there were a lot of maps produced in the last century, not using GIS, where you would have all the polygons, so that no two neighboring polygons have the same color. And also you can see it's kind of like a more saturated color along the border and a less saturated color in the middle. And so it's possible to create this same technique in QGIS like this. So we're going to do the same thing in a few minutes to create the same effect for Danish municipalities. And along the way, we'll see some tricks for both using the cartographic processing tools and this expression-based symbology, which some of you have probably used a little bit. It's basically using these data-defined overrides next to different components of a layer's symbol, and you can override the size of the thickness of a line or the color of something based on an expression or a value in the attribute table. And so we're going to see how we can do that. And then we're going to move into looking at this really special symbol layer type called geometry generators, which allows you to change how the layer is symbolized based on an expression, but you can change the geometry. So you can, for example, show a polygon as points or points as lines or all sorts of things like that. And then we will work with some time-based data, and so how we can make an animation of time on a map. And then we'll look at the 3D viewer and how to work with that. And we'll finish up with this data model called mesh data, which is most commonly used for weather data. So it should be a fun class. So I'm going to get out of PowerPoint. And as usual, feel free, we have a small group, so if you're welcome to stop me with questions. So we're going to start with a blank QGIS project, and we're just going to add the municipalities to it. Let me zoom in a little tighter. So we have this municipalities layer, and if we look at the attributes for this layer, we can see that we have names for the regions. We have names for the individual municipalities, and then a lot of other attributes, which not of them are most of them aren't terribly interesting. They're more about metadata and how the data was processed and updated. So that's what we have in the attribute table to start with. And if we want to color these so that we have a unique color for every municipality, but kind of using the smallest number of colors available and not having two neighboring municipalities share the same color, that's called topological coloring. And there's an algorithm in the QGIS processing toolbox which will compute the topological coloring for a layer. So in the toolbox, there's this section called cartography. And we covered this a little bit when we talked about the style manager, because there are tools in here for working with style databases and things like that. There's also tools for exporting atlases and other things that you might use using the graphical modeler in QGIS. But there is this one called topological coloring that we're going to run right now. So I open up this tool, it says this algorithm assigns a color index to polygon features in such a way that no adjacent polygons share the same color index, while minimizing the number of colors required. So we're just going to use the default values. The input layer is municipalities, and I'm not going to set any of these. I'm just going to use the default values, and I'm going to keep the output as a temporary layer because this is just a demo. I can click run, and QGIS is finished. So I can turn off the original, and I have this new layer called colored. And if I open up the attribute table again and scroll to the right, you'll see now there's this color ID field that the algorithm added. So it goes from 1 to 6. So it needs, in this example, 6 colors to achieve that effect, where we're using the minimum number of colors, but no neighboring polygon has the same color. And we can use this with the categorical renderer to assign those colors. So I can switch to the layer styling panel, and I can choose a categorized renderer. And for the value, I'm going to choose that new field that the algorithm added, color ID. And for the color ramp, I'll choose random colors. And by the way, I realized at last week's or this week's question and answer session, the one thing I forgot to address was how to edit color ramps. And if we have time today, I'll do that. Otherwise, we'll definitely look at that at the follow-up session next week. So it's set to random colors for the color ramp, which I'll keep, and I'll choose classify. So it has given us this effect where we have that minimum number of colors used. And whenever you use this categorized renderer, QGIS will always add this category for null values. We don't have any null values in here, so I'm simply going to select that class and remove it because we don't need that. Another thing with this random colors color ramp is sometimes you don't like the set of colors that it's chosen, and so you can go in here and shuffle the random colors by left clicking on that color ramp and get this menu, and you can choose shuffle, and you can do this until you get a set of colors that you're happy with, and you can always use the undo button to go back to a previous set. I kind of like that. I'll use that. I think it'll work to this effect. Okay, so now what we're going to do is we're going to right click on this layer and we're going to make a copy of it. So I'm going to choose duplicate layer.
Good.
Yes.
Does the function from the toolbox, does that also work? How does it work? Does it work on lines?
No, it's only for polygons.
Only polygons. Okay.
Yeah. Yeah, it would be, you could probably have someone write the same thing in Python with lines, but I'm not sure what's involved in the geometric calculation to achieve this. Okay, so I'm going to turn off the original layer, and I have this layer called colored copy, a duplicate. And by the way, when you have a temporary layer, that's what this little icon in this indicator space in the layers panel means, is that these are temporary layers. And whenever you have a temporary layer, you can always either right click on the layer and choose make permanent to save it to your system and make it a permanent layer, or you can just click that little icon and that'll also just bring up the save scratch layer so you can make it a permanent layer. I'm just going to keep these as temporary for this demo. Okay, so we have this colored copy and we have our 6 colors. What I'm going to do is click the symbol button, which again, this allows me to make changes to each one of these 6 classes simultaneously. So I'm going to check this and select the simple fill symbol layer type. I'm going to change this from simple fill to the one we've used before, shape burst fill. We had used the inverted polygon shape burst fill last week, but here we're just using a straight shape burst fill. And it maintains the colors of each class, but applies a shape burst fill to each. And so I'm going to just adjust the settings for the shape burst. I'm going to use the set distance setting and reduce it a little bit to 3 to make it a little thinner. And then I'm going to increase the blur strength to make it a little smoother. So now we have even already, that's kind of a cool looking effect. And I can click the go back button to return to the main symbol window. So now what we're going to do, this is kind of where that was the topological coloring portion of this. The next part is to create a random dot boundary. If you recall, if we look at this this example here, it's hard to see at this scale, but there's a little kind of light gray hashed series of dots around each polygon, and we're going to use create that by making another copy of this layer and using the marker line symbol layer type to create that. So I'm going to right click on colored copy and duplicate this layer. I'm going to move this to the top of my layers panel. And I'm going to go in here and switch to a single symbol from categorized. I don't need this categorized. I'm going to use the same outline symbol for all the polygons. So now they all have the same color. I'm going to select shape burst fill, and I'm going to change from shape burst fill to a different symbol layer type. There's all these different outline symbol layer types. So with a polygon, these would give you different styles of the polygon boundary, and it would symbolize the layer just showing the polygon boundary, each one of these. There's hashed line, arrows, interpolated line, line burst, and we're going to use this one marker line. And I can show you examples of some of these probably next Tuesday when we have our follow-up. So I'm going to choose outline marker line, and with that, QGIS creates a marker line for the polygon edge. So it's a marker is just a point. So it's creating a point for the outline. And we're going to adjust this marker line. So the marker line has all these different settings, and the default setting is with interval, which we're going to keep. So this is how often the points are placed along the edge. Right now they're every 3 millimeters. And I'm going to make this a very small number. I'm going to make this 0.1. Oops. So they're going to be at this scale really tightly clustered on top of each other. Next, I'm going to choose the simple marker itself, and I'm going to let me see, what's the first part I want to show you. I think first I'll reduce the size of the point. We're going to make it quite small. We're going to make it 0.15. So it's a very small dot. And I'm also going to make the color like a light gray. So I'm going to click the fill color and make the RGB value 90, 90, 90. And just to remind you, if you had black, that would be 0, 0, 0. And if you had white, that would be 255, 255, 255. So anytime these RGB values are the same, it's somewhere on the spectrum of black to white here. So 90 is kind of a dark gray. I'll go back, and I'm going to set the stroke color to the same. And to do that, I'm going to click the drop down for the stroke color, and I'm going to choose pick color. I'm just going to click on that color to apply it to the stroke as well. So now the points are so small, we don't really see them. They're just kind of, it's almost creating just like an outline of the municipalities. But we're going to change that by using one of these data-defined overrides. So these little drop downs to the right of each style parameter are data-defined overrides. So if you click on one of these, you can either point QGIS to a value in one of the attribute fields to define that input, or you can click edit and create an expression. So the one we're going to work with is this offset. So we want these points to be randomly offset from the center, kind of like pepper along the edge of each boundary. And to I have a slide that maybe helps illustrate this a little bit. This was something I originally found on Twitter. One of the main QGIS developers, Niall Dawson, is really is also a cartographer and likes kind of pushing the limits of what you can do with QGIS in terms of styles. So we're going to try to create this effect. This is what I was trying to describe, where we offset those points so that they fall off the boundary, but only on the edge of the boundary, so within a limit. And we can do that by putting an expression into this offset. So I'm going to click this data-defined override and choose edit. And I have the expression on a document here. I'll just copy it and then I'll explain what it does. So this offset is basically an X and a Y, an X and Y offset from the polygon edge. And so it requires two numbers. So we're feeding it. The first one is a 0, and the second one is 3 times a random floating point number to the third power. So that's what we've created. And so I click OK. You just think for a minute, and it applies this effect. So let me zoom in a little bit so we can see what it looks like. So now we kind of have this kind of peppered edge to each polygon because we're using this expression for the offset. And you'll see now that the expression has been used, the offset becomes colored yellow, or the data-defined override is yellow because we've activated it, and it has the sigma on there indicating that there's an expression being used. And if we hover over it, it shows us what that expression is. And a little more on that expression. So the expression itself gives a range from 0 to 3 times that random floating number between 0 and 1 to the third power. So it's using a few different functions. First, it's using concatenate, which is concatenating two strings. First, the 0 is one string, and then this second number created by the second half of the expression creates the second number that are being concatenated to feed to the offset styling parameter. And basically this one number here is the one that controls how far the random dots extend from the boundary. It'd be in millimeters in this case. And so here, setting it to 3 matches the size of the shape burst fill that we set earlier, the width of the shape burst fill, so that it matches the extent of the shape burst. So just to go back to that, if I go to the layer styling panel for this layer that has the shape burst fill, and I click on the symbol, shape burst fill, the set distance is 3 millimeters right here. So here in this data-defined override, we're basically using that same distance. So you could, if you wanted to change the thickness of the shape burst fill, you could go in and adjust this expression to match it. So we're almost done at this point. Now we just need to kind of do the final touches. And we can turn on these other layers. And we want to use a little bit of transparency and a little bit of blending to merge these 3 layers together to kind of create the nice final effect. So this colored layer, I'm going to expand layer rendering for it, and I'm going to give it an opacity of 25%. So I'm going to make it almost completely transparent. And so now we can see the shape burst fill through it. So this layer basically is giving the fill of each polygon, and we can also give it a multiply blending mode to help make the shape burst fill a little more visible through it. Then we can select the shape burst fill layer and expand layer rendering. And here we're going to reduce the opacity of this a little bit as well, but not quite so far. Set it to about 80%. And we're also going to give this a multiplied blending mode. And so now we could also experiment with a multiply or a blending mode for the dots up here. So we could go into layer rendering for the dot boundary, and we could try something like hard light. And that will soften that boundary a little bit. So you can, this is where experimentation comes in. There was no recipe for this. This is something I just spent a day or two tinkering around with a couple years ago and ended up liking the effect when I was trying to duplicate that old antique map look. So this is where experimentation comes into play, but you're kind of being given the recipe for this one look, so you can follow it and see how you might pull something like this together. The last piece we want for this is to add a base map, and what I'm going to use is quick map services. So I know here in Denmark we have data Forsøgning, and you're welcome to use one of those background maps as well. But I'm going to be using one called Quick Map Services, which gives you other global base maps. So this is another plugin. So if you haven't used this before, to install it, you go to Plugins, Manage and Install Plugins, and just search for Quick Map Services. You find that plugin, install it, and then there's just one, so it's very easy to use. You just install it, and then it will show up under the web menu. And there's the only thing you need to do when you first install it is configure it a little bit, because the first list of base maps will be fairly short, just the ones that are involve open services. But you'll see that I also have Microsoft Bing, Esri base maps, Google base maps in here. And that's because I went into the settings for this plugin. And in the settings window, you go to this More Services tab and choose that Get Contributed Pack button. So you click that and press Save. And when you go back to Quick Map Services, you'll see a longer list like this of different base maps you can choose from. So I could, for example, turn on OpenStreetMap. And since I made this colored copy have a multiply blending mode, I'm seeing the OpenStreetMap, even though it's the bottommost layer. So in just a few minutes, I've basically come up with a quick approximation of that antique map look. The only caveat here is that, here in Denmark, there's a lot of municipalities that are separated by a fjord, and technically so you might have some issues where municipalities have the same color even though they're across a fjord from one another. And that's simply because they're not physically touching. So you might have to go in certain situations when you're using topological coloring and tweak some specific features to have different colors. But for any polygons that are physically touching, it works perfectly.
You can just add a number, can't you? I mean, you can make the color 7 instead of the color ID. Give it a number of 7, and then you have no problem.
Yeah, and then you'd have to just go in and like, so if you wanted to change one of the features and add make it number 7, you would open up the attribute table and put it into edit mode and make that, you know, number 7 and save it, and then add 7 here if you wanted to. So I could do that here. I can make this 7 and then go down. Well, I would have to go back and change both of these layers. So this is getting, it would be a little messy, but I can add another class here and make this 7. And then give it whatever color I want.
Or you could have kept the all others.
Yeah, yep, absolutely.
Could you zoom in on an island?
Mm-hmm. Yeah, let's see.
What? So the concat function with the offset, since it's only positive numbers, it puts it inside the polygon, but the reason it's outside is because the polygons, the geometry is smaller than the value of the y.
Yeah, you're talking about like down here?
Yeah.
Where you have a very narrow piece where, yeah, it's narrower than 3 millimeters. So it has no choice but to still put some dots outside, I guess.
Yeah. And they will come up on the other side of the geometry.
But if I zoom in.
Yeah.
Yep.
I just had to wrap my head around it.
Yeah.
Thank you.
Okay, so that is a quick introduction to both topological coloring and expression-based symbols using those data-defined overrides. And we can talk about that more next week if you have questions. But we're going to now look at geometry generators, which is another really interesting topic that also involves expressions in the symbology. So I'm not going to save this. I'm going to just start a new project. Let me see. Yeah. Okay. I'm going to discard all my changes. I'm going to add a different layer. In the geometry generator folder, there's a different municipalities layer. So here in Denmark, a lot of the municipalities have a lot of islands. And so the version of municipalities we were just working on had been dissolved so that every municipality was a multi-part polygon. So a municipality and all the islands that make it up were just one feature in that layer. This version of municipalities, every individual island is its own feature. So there are 99 municipalities in Denmark. So the other layer had 99 features. This one has almost 1,600. There's one for each small island. And we're going to use this to look at geometry generators. So I'm going to start just by giving this a black fill with a white outline like that. Make it easier to see what we're going to do against the municipalities. And I'm going to again right click on this and duplicate the layer to make a copy of it. And I'm going to rename this one centroids. So I'm going to work with centroids here, and I'm going to choose the simple fill, and I'm going to change simple fill to geometry generator. And when I change to geometry generator, I get this interface. First, it's asking me what geometry type would I like, and I can choose polygon, line, or point. So I'm going to choose point. And here, QGIS is giving me the dollar geometry. That's the geometry of each individual feature. And without anything, it basically just does basically the same thing as the outline marker here, where it creates points along all the polygon edges, because that's all it can do at this point. But there's also a function in QGIS called centroid. So I can type centroid in here and centroid just requires one argument, the geometry of the features. So I just put parentheses around the geometry. And now I'm symbolizing the centroid of each polygon. So if you don't know the name of the function, you can click this little expression button off to the right. This will open up the expression engine. And there's these are, categorized by type, and there's a geometry section. And if you expand geometry, there are, I don't know how many, hundreds of geometry functions in here. But the QGIS is very good about giving good help for these. So if I find centroid here in the list, it tells me that centroid just needs the geometry, and it gives an example of using it. And if you don't know where it is, you just remember what it's called, you can always filter by typing in the name up here and finding anything in QGIS that has to do with centroids, and find it that way. And if you've used this expression dialog before, to maybe select features or something, it gives you an output preview, and you'll notice here the output preview is a point geometry. So I can click OK, and now I have my centroids identified. And so if we zoom into Bornholm, this island here, you can see there's a lot of little points along the coast because we are identifying the centroid of each individual polygon in this layer. So I'm going to make another copy of this. And let me point something out. So if there's a weird issue with centroids that you may or may not have thought of before. So this particular polygon has a very strange shape. And a centroid does not necessarily have to fall within the polygon. So the centroid for this polygon literally falls outside of itself. So sometimes identifying centroids doesn't work for some geometries for whatever effect you're trying to achieve. But there's a related function in QGIS. So I'm going to turn on this copy, and I'm going to use the same geometry generator symbol layer type. And I'm going to choose point as the geometry type. And this time I'm going to use a different one, which is called pole of inaccessibility. So let's open this up and search for that. POLE, pole of inaccessibility. So it's a big long name. I'm going to put my cursor in front of dollar geometry and double click on this so that I put the function before. So these functions always have a set of parentheses, and in the parentheses are whatever arguments that function requires. So with centroid, it just had one argument, dollar geometry. That's easy. Pole of inaccessibility has two. It wants the geometry and this tolerance. And here in the description, it says this calculates the approximate pole of inaccessibility for a surface, which is the most distant internal point. So the key there is internal point. So this will the pole of inaccessibility will definitely fall within the polygon, and it'll be the farthest internal point within that polygon. So we can see what the difference will be. So we have the geometry, and we need to put a comma and then enter something for the tolerance. And we can just put a 1 and close the parenthesis. And then we now see that we have this preview of geometry point. And we can click OK. And I'm going to change the color of this to something else so that we can distinguish between the two. So here we can see that's the pole of inaccessibility, and that's the centroid for this particular polygon. In many cases, they'll be almost identical, but for odd-shaped polygons like this, they'll be quite different. And pole of inaccessibility takes a little longer to compute, but now we have done both of those. So you can see for a lot of these municipalities, these two return quite different locations. So one of the reasons you might be wondering, like, why would I want to do this? And the reason is that sometimes you just need to show something on a map. And there are certainly algorithms in QGIS for computing the centroid of a feature. But that involves creating a new layer, a new shapefile, a new geopackage, or whatever. And sometimes you only need it to show on a map. You don't really need the actual data. You just need to show, in this case, maybe the centroid of the features. And so doing this, you can simply render the centroids without having to create another layer. And I think anytime you can get away with not having to create another copy of a layer, it's a positive. So it's one way people use them, but there are other creative ways. So let's look at another example. Let's make another copy of municipalities here. And I'm going to rename this one internal buffer. So I'm sure everyone has used the buffer tool before, where you the buffer operation, like if we have a city, we can say buffer it by 1 kilometer, and it'll create a 1 kilometer ring around that point. So buffer is for creating these measurements of distance around features. And if we use a positive buffer distance, like 1 kilometer, it'll be in this case, we buffered polygons, it would be an external buffer. If we use a negative buffer distance with polygons, it will be an internal buffer. So here, just to show you how this works, I will again switch to geometry generator. And this time we'll keep the geometry type as polygon. Click the expression button, and let's search for buffer. So here's buffer, and it has many potential arguments that it can use, but some of these are not required. I'm going to put my cursor in front of $geometry and double click on buffer. It now needs a distance. And for the distance, I'm going to use, let's see. Yeah. The distance, my data is in UTM meters. So the distance is going to be in meters here. So I'm going to enter a -2000. And that'll be an internal buffer of 2 kilometers, 2000 meters. So now the preview is reading polygon. Click OK. And let me change the color so we can actually see it. If it's black, it won't really show up. Let's make it yellow. So now QGIS is computing the internal buffer for each municipality of 2 kilometers. You can see this one, centroid was really fast. Pole of inaccessibility was a little slower. And this one is also a little slower. Has to go in and compute each one of the 1,600 polygons in this layer. So those are a couple examples of using geometry generators with some easy functions. One thing I don't have a ready-made example of, but another good use case is if you take like field photos, for example, and you have points of photos on the map, and you want to show which angle each picture was taken in, there's another function in here for buffer. If I search for buffer again, there is wedge buffer. Wedge buffer makes like a pie slice, and you can use this to, you can use that data defined override for the azimuth, the direction of the wedge buffer. If you have a photo point and point it to the azimuth in your photo point data, and it will orient that cone or that wedge in the direction the photo was taken. So so that would be rendering points as polygons and using the wedge buffer function.
Good. When you use the centroids, I think what comes to mind is combining it with the point cluster.
Okay. No.
Would you be able to do that without exporting the data to another layer?
No, I don't believe so. I do not believe we can switch to, yeah, this is still a polygon layer. So QGIS still sees it as a polygon layer. So
okay.
So that point cluster renderer would be in this list for a point data set, but we're not working with a point data set here. So it's not available.
Okay.
So that wouldn't work. But let me show you some other interesting examples of this. Yeah, go ahead.
So one would have to like create a temporary, a virtual layer for the centroids, or just a copy.
If you wanted to do that, I would just run the centroid tool. There's a centroid algorithm in the processing toolbox,
yeah.
And that would just create a centroid point layer.
Yeah.
And then you could use the point cluster renderer on that. There's also, you'll see pole of inaccessibility is in here too. So let's see. I have some examples of this, other uses. So this is a nice one. This is from the at the beginning of the pandemic. This appeared in my Twitter feed. And so a journalist from the New York Times used the geometry generator. So at the beginning of the pandemic, all the people who had been living in New York City moved out to like their summer houses and things for to work from there for the pandemic, because they didn't have to be in the city anymore. The office was closed. So this shows where people moved, and he basically just had a point layer. He had a point layer that showed the to and the from locations of where each worker worked. And he used a geometry generator to create these arrows so he's basically rendering these points as lines using an arrow symbol, scaled by the size. And so this is a really creative use of geometry generators, where you're creating this visualization from point data using this probably a pretty complicated expression. He didn't share the expression he used to do this with. So that's interesting. And let's see. I'm just going to open up this website and I'll paste this in the chat. This is a GitLab repository for a guy named Michael Stoitz, a German guy, and he has created a lot of really interesting geometry generator examples. A big list here. And you can download the symbol for each one. So this is a really practical one. So if you have a a parcel boundary, you can use a geometry generator to create labels on the dimensions of each edge. So the green is just a regular polygon symbol, but the line is a copy of that layer styled using a geometry generator, including the labels along each one. And I've used this one before for a very similar case. It's fantastic. He has a similar thing for lines. Let's see. Labels with a leader. That's actually, some of these are so old that some of these things are possible to do without a geometry generator at this point. This is another effect similar to the one I just created using a data-defined override, but he's using a geometry generator to do it. This is a point layer, but styled as 3D buildings using a geometry generator. So you can see there's a lot of different things. Points as tables. Holiday random. So some of them are kind of silly. Some of them are really practical. But you can get, a pretty good idea of some of the ways that you can use these things. Some of them you can get quite complex. Another example of this, that we're going to look at the temporal controller next, and the temporal controller lets you animate time-based data. And a while ago, last summer, a colleague and I went for a bike ride, and I recorded it with my watch and made this temporal animation in QGIS using the temporal controller, which we're going to look at next. But you see this clock on the map. This clock was created with a geometry generator. So this is a single point that is being styled as a clock using some of the time variables that come with the temporal controller to create like an old-fashioned clock on the map that shows the length. So you can do some really creative things. I mean, this one, I probably spent 2 or 3 days on a couple weekends trying to figure that out. It was not easy, but you can do some really interesting things with these generators. And then once you've done it once, you can save that style and use it over again. Another example of these is with last year, a couple more expressions were released. And so see, this is the original layer here. This is just some lines off the coast. And I made a copy of it here. And on the copy, I'm using a geometry generator with one of these new functions called wave. And wave lets you specify the amplitude and the frequency of the wave and change it. So I can, enter different numbers in here to come up with different looks. And that's one of the interesting things about geometry generators, is that you can sit there and tweak the syntax of the expression until you get the look that you want for the map, for the waves in this case. And when this was released, a whole series of these functions was also released. So let me go into PowerPoint again. So this is that straight wave function I just showed you, but there's also wave randomized as another function, square wave randomized, triangular wave, and triangular wave randomized. So those are, another 6 geometric expressions that are in QGIS that you can use with a geometry generator. And the last thing I want to show is, if anyone has ever known about this album or seen this album cover from this 80s band called Joy Division, these are kind of, they're called joy plots now. They've become very kind of popular for people to mess around with and create this kind of effect for real elevation data in the GIS. And you can do that with, as you guessed it, a geometry generator. So this is that Trelleborg data that we looked at last week. Or maybe I can't remember if did we look at Trelleborg? Or did I use Mount Rainier or something? I don't remember. It's one of the data sets that was included in the course data. And so it's this old Viking ring fort. So what I can do is use a geometry generator to basically create a joy division plot of this. And I can go in here and I can change some of the values to how many lines I want to be in the joy plot, and how smooth I want it to be. And even how much vertical exclusion, extruding it vertically I want to create different visualizations of that. So this is another way to visualize elevation data, basically. And you can use this expression. And I'm going to send you all of these expressions in a notepad file after class so you can play around with them. This one has, you can just, it's commented so that you know where to change these values. And it's quite complex, but it's all commented so you can see what's doing what. And then this is the part here, this that has to be set. So let me open up the expression engine for this one. In QGIS, every layer has a unique ID. So there's this section called map layers. This particular function wants to know the layer ID for the layer you're working with. So you can't just type in the layer name. You have to go in here and double click on the layer that you want to use, like this. And QGIS will put in this unique ID for that layer. So QGIS keeps track, it's how it's keeping internal track of layers. And so you have to refer to the layer this way with this function. But otherwise it's quite easy to apply and start to play with. The last example of these I'm going to show is when we looked at working with different coastal effects. One of the effects we didn't quite play with is this one, which is called like basically exponential buffers of off the coast. So you can use it internally for a lake or externally for a coastline. And this function here is what can be used to create it. And you always have to, with these, it depends on the scale you're working at and the coordinate system you're working in, where to place these. But I'll feed you this function too, which is also commented, and you can experiment with different values. This one takes a little while to compute, but it's quite a beautiful effect to be able to apply to a map and can really set your map apart from others. So this is another geometry generator example. And so, basically there's a lot of examples here, and there's no like recipe book. This is simply people figuring these things out over time. So there are 100 or so geometric expressions in QGIS, and pretty much everything I would say is possible if you can imagine it with using these expressions with the geometry generator. It just may take a little time to figure out, but it's very powerful, and it's unique to QGIS. There's no other GIS that has this capability. So let's take a 10-minute break, and when we come back, we'll start looking at the temporal controller. Thomas, are you there? Wait a second to see if he comes back. Oh, there he is. Okay, so we're gonna switch topics and talk about the temporal controller. So the temporal controller allows you to work with GIS data that has a timestamp associated with it, and then basically filter the map for features that occur in a specific time frame, but also export still images and be able to create an animation through time. So here we have a building point layer, and the data have been styled by construction date. Excuse me. See, there's a filter here. And the filter, when I hover over it, says that it's excluding data where the year equals 1000, which in this part of the world could be a valid construction date. But in this case, the year 1000 was used as a no data value, which is a little strange. But so I'm filtering out the 1000 data because it was no data. And so we have a graduated renderer with a green to red color ramp, and the oldest buildings are in red, and then newest buildings are in green. And another trick that's already being used here is when you do this, there's by default, QGIS doesn't really control what gets drawn on top of another when you have a bunch of points like this. But I can go down to this advanced section and open up the properties for symbol levels. And symbol levels basically lets me tell QGIS what order I want these different classes drawn in. So here, the oldest class is 0, so that means it would get drawn first. The newest class is 8, so it means it would get drawn last. So the newer points are on top of the older points. You know, you could reverse these numbers and have the oldest points drawn on top and the newest points drawn on bottom. So you can always control how a series of points like this, or even lines or polygons, are rendered on the map by telling QGIS what the order is in this column here. So this was blank by default, and I went in and I just entered 0, 1, 2, 3, 4, 5, 6, 7, 8 to create that. So I'm going to open up the temporal controller panel here. This little clock icon opens up this panel, which shows up as a panel across the top of the map. And by default, temporal navigation is disabled, it's turned off. And I'm going to first configure the temporal properties for my building layer. So I'm going to right click on buildings and open up properties for it. And on the properties tab, you'll see that there's a temporal tab. And so I can enable dynamic temporal control, basically tell QGIS that this data has some time associated with it. And there's a few different ways to do this. I can choose a fixed time range. And for example, if my data does not have time attributes, but I know what time it occurred during, I can go in here and just enter the start and end date for time myself using this fixed time range. But there's also the options here for setting it to point to a specific field in your attribute table that includes the date and time, or separate fields for start and end date or event duration. And we'll look at redraw layer only too. So we do have a field that has the date and time. So I'm going to choose this option. And QGIS will, for this to work with QGIS, you have to have a date time field type. So, you know, when you create a new field in QGIS, you have to choose the type. Is it text or string, as it's called, or a number field, or is it a date field? So you have all these different field types. And so QGIS is only going to pick up on date fields here. And I have other options here. I can choose to accumulate features over time or not. So I'll click OK with that. And now I have another little indicator over here, a little clock, and that means that QGIS now knows that this is a temporal layer. So I can now, on the temporal controller panel, click the fixed range temporal navigation. And QGIS picks up the entire range from the first year of my building data is from 1150, and the data goes up to the end of the year of 2020. So I have almost 1,000 years of data, 900 years of data of buildings here. And I can set the beginning or end. If I have multiple layers in my map that are temporal layers, I can choose to set to the full range of all the layers in QGIS or to a single layers range. And then this third button is the animated temporal navigation controller. So with this set, I get this time slider and these play buttons. And so I can start sliding through time here. And I see most of the time scale, not much is happening. There's basically one old church that was built in 1150, and then there's several centuries where there are no existing buildings. If I continue, you can see the buildings start to appear. So I can scrub through time using this slider like this. I can also choose the step, so how long each frame lasts. So I could choose, instead of 1 year, I could set it to 10 years, and then, have it would go faster. And you can set the units anywhere from milliseconds up to centuries. So here, since I don't really have much data, the current frame is always going to be displayed up here, so I can see 1838, where I am now. I'm starting to get a few buildings. But it's not really till around 1850 that I start getting anything really interesting appearing on the map. So I could set the animation range to reflect that. I could set this to start at 1850 instead of 1150. And now I've narrowed my time frame. And as I slide, you'll see the time change up here. But that's the only place I'm seeing time right now. So that's kind of unfortunate. I'm going to show you how you can fix that here in a minute. So there's also this export button here. So this would allow me to export out the animation as a series of PNGs. And then I can use something like GIMP or Photoshop to stitch those together into an animated GIF or an MP4. But first, we're basically here designing the map in our map canvas, not in the print composer. So there are some tricks we can use to make the map a little nicer. If I go to the view menu, it's kind of this overlooked section, there's decorations. So I could add a title label, for example. I could enable title label and put in the name of the town. And I can then change the font, the background color, where it's going to be placed. So I can hit apply, see how that looks. So maybe I'll use a white font and make it a little bigger. So you can set up a title font using this little widget, so you have a title on your map. There's also I created a legend graphic in the print composer, and there's an option from these decorations to add an image. So I could browse to my legend that I put into the course data. So I go into our course data, into buildings. There's a legend graphic. So I can put that on the map. And by default, it makes a little small image down here. But I can tell QGIS how big I want that to be. So I can increase the size. And then I can use the controls here to shift it into a location on the map where it fits. Well, maybe I'll just keep it where it is. That's good. But I could, move it away from the edge a little bit by adjusting the vertical and horizontal numbers here. So now we have a legend graphic and a title on the map. But the one thing we're missing is the date. And that's really nice to have the date when you're working with temporal data, because that's the whole point. And we can see it up here, but we can't see it on the map. So what I can do is create a new layer for that. So I'm going to go to the layer menu, create layer. And I'm going to, for this demo, I'll just create a temporary scratch layer. And I'm going to call this time label. And I'm going to make it a point layer. I'll put it into the same coordinate system. And that's all I need. I don't need any attributes. I'm going to click OK. And now I'm simply going to use the editing toolbar to put a point somewhere kind of in an empty space where I want to see the time displayed. Maybe right there, and then stop editing. So with this time label, I'm going to use a label to tell QGIS what the time is on this point. And I don't have any attributes for this layer, but the temporal controller comes with some variables for time that I can use. So I can choose a single label, and I'm going to open up the expression engine because I don't have any attributes to label it with. I'm going to open this up and I'm going to search for time. And you'll see there's a variable for map end time and map start time. So this is the start of the map's temporal time range. So I can click OK. And I still don't see anything on the map. And one thing we have to do is we have to tell QGIS that this is also a temporal layer. So I'm going to right click on it and open up properties. And I'm going to enable dynamic temporal control. And I'm going to choose the option redraw layer only. So the time is going to come from the variable that I had set. So I need to tell QGIS to redraw a layer only. So every time frame, QGIS will just redraw this layer so that it'll update the time label. And somehow my value didn't stick. Let me try that again. Time. Map start time. Okay. So now I have my time displayed on the map, and I can adjust the font for it since it's a label. But this is also quite a bit of information. I don't need the hours, minutes, seconds when I'm dealing with 900 years of time. I just want the year. So I can go in and edit this and format my timestamp. There's a function in QGIS called format time, format date rather. So I can choose this format date function. I'm going to put it at the beginning, and map start time will be one of the variables for this function because it requires the date time. The map start time is going to be the date time. And then I can just enter a formatting tag. And you can see here are all the different formatting tags for different pieces of time. So if I just want the year as a 4-digit number, I just need these 4 Ys. So I, after my parenthesis, enter a single pick, an apostrophe, and put Y, another closing, and then close the parentheses. And now you'll see that my preview is just the year. So you can set up the formatting for the date as you need it. I can click OK, and now I just have the year there. And I don't really need that point sitting there. So I can switch to the symbology tab and choose no symbols for that, so that I just have the label and no symbols for the point. And maybe I can go in and increase the size a little bit. So now we have the date on the map. So as we scrub through time here, we're going to see that date update. I need to update my animation range again. Somehow that got lost. They're starting at 1850 and going all the way through in steps of 1 year. So you can also press play, and QGIS will just play the animation at 1 year frames.
So why is it the start time? Is it because it's the start time of every
frame?
Okay.
So here's your current frame, and it has the start time right here. So it has every frame is 1 year because we have it set to 1 year. So having the map start time works great for placing time on the map.
I would never have guessed that. I would have guessed that it would be called current frame, because in my terminology, start time would be the first year.
Yeah, it really, I guess the variable would be better called frame start time. But really what it is the starting time of the map frame.
Because the map end time variable will do the same.
Yep.
Okay.
Yeah, in our case, it wouldn't matter which one we choose, start time or end time. It's going to be, since every frame is 1 year, it would be the same.
Okay.
Check my notes. So yeah, so we can go ahead and if we wanted to, we would export this out as a series of still images. And then I have some instructions that I'll send you on how to stitch this together into an animation. It's pretty straightforward. For example, there's an open source software called GIMP that is kind of the open source Adobe Illustrator for working with imagery. And there's really only 3 steps to save something as an animation. You open up GIMP, you go File, Open as Layers, you select all the images, you then go to Filter, Animation, and choose Optimize for GIF, and then you export it. And you just will export out an animated GIF of your result. And you can choose the delay between frames to speed up or slow down the resulting animation. So it's fairly simple to do that. And we have a lot of time-based data, so creating an animation can be quite a bit more interesting and intuitive for people to see some kind of trend through time in whatever data you're working with than seeing a bunch of still images. So I think this is kind of one of the new areas of GIS, is kind of involving this 4th dimension of time to what we're working with. And this temporal controller works with all data sets. You can use it for rasters, vector data, and the last thing we're going to look at is mesh today. So let's see. The next thing we're going to look at is the 3D viewer. Let me see if I can't remember if I had an example, any examples of time. I do have other examples of temporal animations that I've created that I can show at the follow-up session, or if we have time at the end of the day. I want to make sure we get through everything first, and then we can go back if we want to revisit something. Okay, so I already have the Mount Rainier project open here. So this is that 3D view, or 2.5D view actually, of Mount Rainier, where we've used the hillshade renderer and the color DEM and the contour renderer to create a nice effect. And one feature that kind of ties in with 3D that's fairly new to QGIS, I want to show you. It's the elevation profile tool. So from the view menu, I can choose this option for elevation profile. This is new as of 3.26 or 3.28. I can't remember which version it came out in, but it's in the new long-term release, which is what I'm working with. So I can open up the elevation profile, and it opens up a panel down here. And I can open up the layer properties for my DEM. And I can tell QGIS that this represents an elevation surface. I was playing around before class. This is not enabled by default, so you have to go in and check this and tell QGIS that this layer represents an elevation surface. And then you have some options for styling the profile chart appearance. So as we draw a line on the DEM and we want to see the elevation profile, we can choose how we want that elevation profile to look. So you can choose a line, and so you could make it just a black line, for example. But there's other options. There's fill below. So here I could use a color ramp, and I could use the same kind of terrain color ramp in my elevation profile that I used for my DEM. So I could go in here, and this just involves switching into a different symbol layer type. So instead of using simple fill, you can choose the gradient fill. So we're slowly getting to see a bigger array of all these different symbol layer types as we go through these exercises. So here's gradient fill. So gradient fill just symbolizes a polygon basically on a gradient from one color to another. So I can choose to use a color ramp. And in that case, I can use the same terrain one that I used to color the DEM. And I think I just need to invert it. So the higher elevations are on top and the lower elevations are on the bottom. So I can click OK. And now I can, in the elevation profile, I have a couple options. I can, on this first one, capture a curve. That means I can just draw a line on the map and get the elevation profile. So I could draw a line across here, right click to finish. And there's my elevation profile of the line I drew. And as I move my cursor around in the plot, you'll see a little line move along the line I drew, showing you where I am at that particular point. And it'll also give you the X and Y values, so you can see where you are. There's even a measure tool, so I can measure how far it is from here to here. It gives me the total length, and if I've changed elevations along my line, it gives me how much I decreased in elevation across that line during my measurement. There's another option here. I have this line layer in here, which is the standard route up this mountain, a hiking trail. You just crashed. Let me open that up again. open up the profile tool again, make sure my settings are all there. So there's a button here to capture a curve from a feature. So here I can click on an individual feature on the map, which is my hiking route, and I can see the elevation profile for that hiking route. That's another nice option. So this is very much related to 3D, which is what we're going to look at next. So if I want to bring this into 3D, it's quite simple. I can go to the view menu here, and I can open up a new 3D view. This is actually a new feature. Before this latest release of QGIS, before this long-term release, you could open up a 3D view, but it would go away as soon as you close the project. There's now a 3D view manager, basically. So we'll show you how that works. So I can open up a new 3D map view. And this is a panel. And like most panels, it will want to dock to different parts of the interface. Oh, where is that? So in its default mode, you can see it's going to try to dock to different parts of QGIS as I move it around. And when I'm on a laptop, that's kind of annoying. So there's a button off to the right side of it to undock the 3D map view and make it its own free-floating window. So when I do that, I can resize it as I want to, and it's not going to try to snap to the rest of QGIS, which is nice. So I've got my 3D map view, and I just need to configure the view and tell QGIS where the elevation is coming from. So I'm going to click on the little wrench and choose configure. And I'm going to tell QGIS that the type is a DEM raster layer. And this is always annoying to me. It's kind of feels like I've made a mistake, but I just have to tell it that the elevation layer is the DEM. And then I can click OK. And now I can start to use these controls on the right to tilt the terrain into 3D. I can use the compass to spin it around. And I can use the mouse to pan back and forth. Whoops. Now it's Windows 11 that's trying to make it snap. So another nice feature of this 3D environment is pretty easy to set up is I can create a 3D animation. Let me, just one other thing. Sometimes you see that little sliver right there, you're getting like a little artifact where it's not quite rendering smoothly. That can be fixed from this configure menu where I was before. It's the skirt height here that you need to increase. So if I just increase the skirt height to like 100 from 10, it should take care of that rendering artifact and make the terrain smoother. So what I can do if I wanted to create an animation here is click this little play button, animations, and this little panel opens up at the bottom, and I just have to start entering keyframes. So I could say, okay, this is where's 5? I'm gonna remove that. I could say this is where I want QGIS to be at 0 seconds. And then I can spin it around and say, click the plus again, and okay, at 2 seconds, I want it to be here. And at 4 seconds, I want it to be here. And then I'm going to zoom in. And so you can just keep adding keyframes until you get the view that you want. And then maybe, zoom all the way out for the final, make that at 10. So you can enter as many of those as you want, enter any timestamps you want, and when you're finished, you press play, and it will basically stitch that all together into one smooth animation. And you could create an animation like this, just like you would with a temporal controller, by clicking this save button. And again, you're going to be exporting out the frames in the same way. So you choose a folder where you want those individual frames to go, and you click OK, and QGIS will export out all those frames, and then you can stitch them together into an animation. And again, this 3D viewer works with any kind of data. You can extrude 3D data. You can see that the trail is being draped on top of the elevation surface because it knows that's the elevation surface. And so you can also take like buildings, or if you had, and extrude them into 3D and things like that as well. You can also create, sometimes you can save things as 3D features. So there's a lot of support in here for different things. But I will say this is probably one of the, the 3D environment is fairly complicated to develop. And this is still suffers a little bit from being kind of a new feature in QGIS. And sometimes it crashes or what have you. But you can, it's getting better. Like every release of QGIS, it gets support for more and more features. So one of the recent things is that it now has support for point clouds. So if you bring point cloud data into QGIS, you can bring it into 3D, and it automatically recognizes the elevation component. And it has this option to export the 3D scene. So if you want to continue this in a software like Blender, another open source project, you can export this out and pull it into something else and keep working with the 3D scene in another software. So there's that 3D view manager. So if I go back to the view menu, you can see I have one 3D map, and I can choose manage 3D map views. So I could select this and rename it Mount Rainier 1, and I can choose that and duplicate it so that I have 2 views now in my project. So here's the second one. And so you could save multiple views, and these views also honor map themes, which identify which layers are taking part in the map. And so you can have different views that are tied into different map themes, for example. So this works a lot like the print composer manager, where you can have multiple 3D views saved in your project now. And so when you open up the project, they're all saved and you can open them up again. Any questions on that?
The root?
Yeah.
Where did you get the root from?
Oh, I'll give that to you. It's from a chapter in my Discover QGIS book, and I forgot to include it in our course data, but I will email it to you with the assignment today.
But it's just with set coordinates or what?
It's just a line layer. It's
Yeah.
just a shape file.
But it has an X and a Y and a Z coordinate to have the elevation or what?
No, it's getting its elevation from the DEM because QGIS knows that the DEM is the elevation surface for the
Okay.
project.
So it could be any kind of line,
Right.
or not kind of line, but any line. Okay.
Yeah. So one thing I want to just quickly let you know, these are also fairly new features, is that there's now an item in the print composer for adding a 3D map. So I could add a 3D map to my print composer and tell QGIS to copy the settings from one of my 3D views. And there's my 3D view now on the print composition. And in the latest release of QGIS 3.3.0, I'm in 3.2.8 here, so I don't have it, but 3.3.0, there's a button down here for adding an elevation profile to a print composition as well. So at 3.3.0 and beyond, you'll be able to add those elevation profiles to a print map. And there's also with 3D, there's a notable plugin I should quickly mention. Do I have that slide here? Yeah, QGIS to 3JS. So this plugin works really well. And what it does is it creates, it has a 3D viewer, which is nice, but it basically creates a website, a 3D view as a website, and it performs really well. So if you wanted a 3D view on your website, for example, you could use QGIS to 3JS to export that out. And it exports out all the JavaScript and HTML that's needed. And then you can just open up that 3D view in your web browser. And like, for example, with this Mount Rainier data, it feels like it performs even more smoothly than the native QGIS 3D environment. This plugin works really well, and it works with point clouds, raster data, and vector data. So you might want to explore this plugin and see what it can do. So the last thing we're going to cover here in the last 20 minutes is mesh data. This is probably the thing that pertains to your day-to-day job the least, I would say, for most of you, knowing what I do about what you do for work. But it's a fairly new supported data model in QGIS, and you can do some really cool things with it for data visualization. And one of the things it excels at is storing weather data. So you can use it with the temporal controller in QGIS to create animations like this of a series of hurricanes going through the Caribbean in 2017. And so mesh data is kind of a hybrid data model. It has sections that can be styled like vectors and other components that are more like raster data. And it's used a lot for weather data, oceanographic data sets, and kind of different kind of model outputs from those environments, flooding scenarios, and things like that. And the mesh data can have several data sets within it. So the data set I'm going to show you is for a big storm that hit Denmark, the December hurricane in '99. And so it has wind, temperature, and precipitation, all as parts of it, and time. So we're going to look at this December hurricane, which I think is still the highest wind speed ever measured on Danish soil. So it happened in December of '99. And let's see. So the data source for this is this Copernicus climate data store. They have this data set, this ERA hourly data from single levels, and it goes all the way back to 1979. So you can extract data out of here for any time period all the way back to 1979, which is pretty amazing. And I specifically, you can go into their data viewer and set up which parts of the data you want to download. what the spatial extent is, what time period, and it will give you this file, which is a GRIB file, which is one of the formats for mesh data. So here we're pulling in precipitation, wind, and temperature. And we're going to be able to create an animation like this using the temporal controller of this storm passing over Denmark. So it's fairly easy to pull in. So I'm going to start with a QGIS project, and all I've done is open up this project, which has countries and the boundary of Denmark, and then it has this one mesh layer. So if I open up the browser panel, this is in our course data, and this mesh data has a different looking icon than you've seen before, and it's a .grib file. So the Danish Meteorological Institute uses a lot of this data, for example, and other international meteorological outfits. And so this was extracted from that Copernicus data store and just dragged into QGIS, and this is what it looks like by default. And when you add it to QGIS, it will come in already knowing that it's a temporal layer. The QGIS automatically recognizes the temporal component of this GRIB file. I didn't have to do anything. Now, if I open up layer properties and go to the temporal panel, you can see that it's for a couple days in early December 1999. So we just need to do a little styling to this, and the layer styling panel looks quite a bit different for mesh data than vector or raster. It has these different tabs that we'll look at, and it has different data groups. So it has precipitation, temperature, and wind. You can see the colors that we're looking at on the map right now are the wind, but we could look at temperature or precipitation just by checking those and highlighting each one. The vectors that we're going to look at are only available for wind. So we're just going to map the wind component of this data set to begin with. And so we can customize the way this raster component looks by switching to this tab here. And in the mesh world, these are called contours, even though it's looks like raster data, the way it looks on the map. So we can choose a color ramp. And instead of this magma color ramp, let's choose one that's red, yellow, blue. And I'm going to invert the color ramp so that the blue will be the lowest wind and the red will be the highest wind. So we can change the way this data is stretched also by changing the min and max values here. So this is the full range of values, but I'm going to set the high to 20 to kind of put more emphasis on the higher wind. And I can already start sliding this slider through time on the temporal controller panel and see the storm starting to approach, so that dark red is the higher wind associated with this storm. So you can see the storm sitting over Denmark right there on the 3rd of December that day. So next, we want to turn on the vectors. So I can check this vector box over here and then go to the vector tab. So these are what the vectors are set up to look like by default. They're black. I think I'll make them a dark blue instead, so that they will blend into the map a little better. And we have some settings down here that we can use to make them look a little better. We can check display on a user grid, and we can set how dense we want that grid to be, like this. And down here under arrow length, we can define how these arrows look. So instead of defined by min max, we can choose scale to magnitude. And it gets a little crazy with this scale factor of 10. We're just going to make that 1. So now the arrows are going to be scaled to the size of the wind that's happening. And the wind arrows are, nice. They really show the circulation of the storm. But arrows are just one choice. There's also streamlines and traces. If I choose streamlines, it gets a little busy. We may need to, if we were going to use this, might need to reduce the spacing to make it a little less dense. That didn't really help. I've never really liked this one particular setting for the vectors, but traces is really cool. It's kind of what we get with a lot of wind simulation software. So with the traces, we're really starting to see the circulation of that storm a lot better. And there are other settings you can set in here for the number of particles to count. You can reduce or increase some of these, so you can experiment with that, along with the tail length. So you can experiment with different tail lengths of the traces. And see what that does. So at this point, that's really all we'd have to do a nice animation. And the rest is just using what you know already from the temporal controller. We could add a point layer. We could go to create layer, temporary scratch layer, and call it time label, just like we did with the buildings. And we could put the time label where we want it to go. Again, use no symbols for it, but configure the labeling expression. Oh, shut off my other window. At start time. And we can use that formatting tag. And here we definitely want more like hours, minutes, days. So we could do something like hour, colon, minute. DD, MM, Y, like that. And we also need, remember, there's this one setting for this. We need to go into properties and set this temporal layer to be redraw layer only with the time label, just like we did with the buildings. So give it dynamic temporal control and choose redraw layer only. So every map frame, this layer will be redrawed, and QGIS will pick up on the timestamp. So now we have the hour and date there on the map. And we could just start playing time and watching the storm pass. This isn't as smooth as the buildings because it's a bigger data set and it takes my laptop a lot longer to render it. So it gets a little rough. If you export it, it would be very smooth because it exports each image individually. But another option you have with this kind of data is to not show the contours. Why is it not showing? Transparent, and changing the wind traces to be white, and you can just show the wind traces on a satellite image like this. So those are probably the two most common ways people work with this kind of mesh data. And again, I don't have any example data sets, but it's also used to show potential flooding in an area under different scenarios. And then when you wanted to create the animation, it's simply exporting the animation just like you would with the building example.
But is mesh data, does it always have time in it?
Most of the time. It doesn't have to, but that's
but it's both raster data and line data.
Well, it's more it's kind of the way it's being symbolized here. So it has it's really structured as a mesh, as the name implies. So if we go back to this slide here, you have three main structures of mesh data. There's triangular mesh, quad mesh, and mixed mesh. What we're working with here is a quad mesh with this data set. And so if you've ever had, I used to use Esri software a lot, and there was a data model that Esri had for working in the 3D environment called a TIN, a triangulated irregular network. And that is mesh data. So mesh data is a series of faces and edges that can be used to represent terrain or this kind of data. And it can have, so that's the physical structure of it. And when we're looking at it in QGIS, there are just these different rendering tools here for showing it. So we can render it as these traces. We can render it as kind of a raster background in different ways. So we can show it, we can symbolize it in different ways, basically. But the structure is that underlying mesh.
But so there's also a grid tab.
Yeah, okay, so this one over here shows you the native mesh rendering. So it's gonna show you the structure of the mesh. So you can see it's a regular grid. And this over here is basically some statistics, like a histogram of the data.
But the same data set, the one file, both contains the meters. So it really has in the same file 3 different data sets.
Yeah, it has meters per second for wind, temperature in Celsius, and precipitation.
Okay.
And you know, I've gotten some data sets from DME, the Danish Meteorological Institute. They put out daily grid data from meteorological observations, and some of their data sets will have 30 different elements in it.
Okay. And there's no attribute table for it, and you can have a look, see what it does.
Nope.
Okay.
Nope. But you'll see there's this mesh menu up here, and so there's other tools related to mesh. There's a mesh calculator, like there's a raster calculator, and there are processing tools around mesh too. So it's a bit of a specialized topic, but there's a lot of tools in QGIS for working with it, which is why I like to cover it in this course. And the data like these are you know, easy to access and use. And so yeah.
Okay.
For those of us that are working with, parcel boundaries and things like that, we may not use this, but it's good to know what's out there.
I'm not sure it applies to my job as well, but
Yeah. All right, so that's the course. We got through everything. And I already have some ideas on several topics we can cover during the follow-up session next week, but I'll be sending you the recording of the class and the assignment, and I'm going to send you some text file with some of those geometry generator expressions as well, so that you can use those. And I'll send that Mount Rainier Trail data set too. So if you want to experiment with that, you can. So any final questions or thoughts? Nope. All right. Well, thanks everybody. I'll be in touch and I'll see you next week.
yes,
Thanks. See you.
goodbye.